Okay, good morning, grade 10. I would like all of you to turn to, I think that's a 20. Okay, let's turn to page 21 in our new booklets. I believe they're pink. Hey, we're talking about 4.2. I know that there's a lot of you that were not here last Thursday or Friday, so you need to be making sure that once this lesson is done, you are going to be going back to all of the notes that we had done, okay, last Friday, and then if you weren't here Thursday as well, you also need to go through Thursday, but you should be taking out your phone for the one note after this is done, and going back and making sure that that is all correct. Otherwise, moving forward, you're going to be a little out of practice. Okay, so we are going to be moving on with our integral and negative exponents. But before I can even begin with integral exponents, we're going to kind of do a quick little recap of what we were doing last week. So on Friday. So kind of keep in mind all of our exponent laws. If you always need to come back to this, you can. This little blurb about carbon dating, this kind of gives you an idea, okay? And I like taking this kind of information for all the people that kind of say, why are we learning this? When in the world are we going to be learning this in our real life? Okay, this is kind of an idea of that, okay, why we have integral exponents. So I'm going to just do kind of a quick little recap, and then I'm going to do some word problems, and you guys are going to finish this lesson by yourself, okay? So it says write each product or quotient with a single exponent, but we need to be making sure that we're going to have our answer with only positive exponents. So I have 5 to the power of 8 times 5 to the power of negative 3. So I have a base of 5 that's not changing. When I am multiplying bases that are the same, I'm going to add my exponents. So I should have 8 plus my negative 3. So my answer here should be 5 to the power of this one's positive 5. Okay, I have a positive exponent. This is my final answer. It does not say evaluate it all. It just says write it as a single exponent. So this is my final answer. Okay, then this one, I have 0.8 to the power of negative 2 times 0.8 to the power of negative 4. Okay, so again, I'm going to be making sure I have 0.8, and that's negative 2 plus negative 4. So my answer here is going to come out, I'm going to have 0.8 to the power of negative 6. Okay, this is technically an answer, and if you were to type this into your calculator, you would get an answer. However, we don't want negative exponents. So we learned last week, that anything that has a negative exponent, okay, can be written as the same if it was taking the reciprocal to it and if I were to have a positive exponent. So I'd put it underneath the fraction or above the fraction if it was below, and I'd get the same answer. So this 0.8 is up top, okay? So I'm going to move it to the bottom. So I'm going to 1 over, okay, 0.8 to the power of positive 6. Okay, it's kind of weird to see this decimal as a fraction. Okay, so another way that some of you might want to write this is I know that 0.8 can be written as 8/10. Okay, 8/10 all raised to the power of negative 6. Okay, so if I really wanted to kind of flip this around, I could have my final answer would be 10 over 8, okay, with my negative 6 at that point. However, we can keep this. Okay, we're going to leave it as my decimals in there for now. Okay, so this would be my final answer. Let's go to this one. So C, this will be one of the last ones that I do because it is just a recap. Okay, so I have x to the power of 5, and then I'm subtracting negative 3. So 5 minus negative 3, that technically is 5. This turns into a plus 3. So my answer is going to be x to the power of positive 8. My answer is positive. I'm leaving it at that one. Okay, so we're just needing to be making sure that if I have a negative exponent, I'm moving it down. And then if you have a positive exponent, kind of switching it that way. Okay, I'm going to let you guys finish these off, okay? And you're going to do the your turn, okay? But I want us to kind of skip to example 2 right now, okay? Just because I have a couple people who weren't here, so I want to make sure I'm going over these again. So here I technically have a phantom 1 on my m, okay? That's my positive exponent. I have n to the power of -3. It says write each of the following only using positive exponents. So my m is going to stay up top, and then that -3, I'm not going to write it up top with this m anymore. I'm going to move it down to the denominator, and I'm going to make it a +3. Okay, and I'm going to leave it like that. Okay, please make sure that if I have a negative coefficient, that you're not moving that negative coefficient at all. Okay, these are all of the same that you were doing. The only difference is that if you can evaluate, it says evaluate. So that means that anything that has a number or a coefficient that can be evaluated, I want to actually know what that answer value is. Okay, so you're going to be evaluating that one. So you're going to be doing these ones. Okay, there's just a couple multi-step, but you need to be making sure that you're following your BEDMAS. Okay, and we're going to skip forward to example 4, just because this is a little bit different than what we were doing before. Okay, so it says a culture of bacteria in a lab contains 1,000 bacteria cells. The number of those cells triples every day. This relationship can be modeled by the equation n is equal to 1,000 times 3 all to the power of t, where n is going to be the estimated number of bacteria cells. Okay, so I know that that's the number of bacteria cells left over. And then t is going to be the time in days. So it says how many cells were present after 1 week. Okay, so if it says that it's the time in days, and I need to think, well, how many days are in 1 week? Well, that's 7 days. So I'm going to rewrite this equation. So I have n, which is what I'm trying to solve for, is equal to 1,000 times 3 all to the power of 7 for that total 1 week. Okay, we're going to take out our calculators. I don't have this one. So 1,000 all to the power of 3. Okay, so we're going to get a really large number. So I should get 2, 1, 8, 7, 1, 2, 3. Okay, so that's how many bacteria cells. So this is the total amount of cells. Okay, so that one's a pretty straightforward one. The next question says how many cells were present 3 days ago. So that means past tense. Okay, so I'm going to do the same equation. So n is equal to 1,000, okay, times 3, but then it's 3 days ago. So that's going to be my negative number. So I actually want -3 to go up as my time, okay, because that's going to be backwards. So now I'm going to type this into my calculator. Okay, so I'm going to have 1,000 times 3 all to the power of -3, because that's still in days. And my answer is going to be approximately, I'm going to kind of do a wavy line because it's approximately, we're going to say 37 is what I get, 37 cells. Okay, so we kind of, when it comes to a quiz or when it comes to a test or something like that, you just have to make sure you're paying attention to the wording. Okay, so it doesn't want to know how many is going to be after a certain amount of time, which is at 7 days. Okay, or is it going to be past tense, which I need to kind of take a negative approach to that one. Okay, you're going to do a your turn question, and then there's going to be a question here. It says calculate the value of x that makes each statement true. So you kind of need to think you're going to be working a little bit backwards. Okay, these ones are kind of challenge questions, so I'm not going to want to do them with you just yet. I'll check in with you guys tomorrow on it. So it's saying 2 to the power of x is equal to 16. So I want to know 2 to the power of what is going to equal 16. Okay, so you need to tell me what x is going to be. Okay, and then same thing up here. So if I have 9 to the power of x plus 1, that has to equal the same is 27 to the power of whatever that 2x is. And then the x for both of these has to be the same in each statement. So you guys are going to be playing around with that just a little bit. Okay, so these ones are challenge questions, but I want you to try them out because they're hint, hint, nudge, nudge will be questions like this on your quiz and test. Okay, so that's kind of a really quick recap, okay, of what we've done. So you guys need to go back and you are going to complete from page 21 all the way to page 23. And then starting on page 25, you have an assignment, okay, that it's going to be, again, we're dealing with positive exponents. It says simplify each of them, then restating them in positive exponents, couple word problems, and then your answers, you know, where you can find those. Okay, you have all block to do this, so please make sure you're taking your time. Okay, and again, if you weren't here last week, which there were many of you who were not here last week, this is when you have permission to take out your phone and log on OneNote and go back and make sure you fill in all of these pages that you missed. Okay? Good luck. If you have any questions, you can message me on Teams, or I will be back tomorrow and we'll kind of do something really quick before. But just kind of quickly checking our calendar here. Okay, so you guys do have a quiz tomorrow. I will do kind of a quick little check. It's going to be on 4.1, 4.2, so it's going to be dealing with those negative exponents, and you may see a word problem on your quiz. Okay, you have a quiz tomorrow, a formative quiz, and then you also have a formative quiz on Friday. Okay, so good luck.